scientists around the world are perplexed. Findings from the James Webb Space Telescope have called the Big Bang Theory into question. Joel Rohn takes a deeper look at this telescope's latest discovery, which has revealed the shocking disappearance of 900 trillion stars. The $10 billion James Webb Space Telescope has been operational in space for over 2 years, but the results already prove that its investment has been worth it. The telescope far surpasses Hubble, providing unprecedented views of deep space. In July 2022, James Webb began exploring extremely long wavelengths coming from distant galaxies, detecting radiation outside the visible range known as redshifted ultraviolet. The telescope has revealed astonishing details that were beyond our expectations, showing areas of space that Hubble could not observe. Most disturbingly, however, James Webb has discovered the unexplained disappearance of 900 trillion stars in the vacuum of space. This finding raises disturbing questions about how these stars could have disappeared without a trace, and each new piece of data adds an air of mystery and concern. In a surprising observation, the James Webb Telescope has detected the disappearance of trillions of stars without a trace. The question is, where have they gone? There are two main theories about this phenomenon. The first suggests that the stars are still present, but their death could have been accompanied by a lowered luminosity, perhaps hidden by dust, or that they have simply collapsed into black holes without going through a supernova stage. The second theory is more alarming. It could be that the universe is in a process of disappearance that we cannot stop. Almost a century has passed since scientists theorized that the universe was expanding and that the most distant galaxies appear to be moving away from us at an ever-increasing speed. This expansion does not mean that galaxies are physically moving through space, but that the fabric of space itself is expanding, leading galaxies to move away more quickly. This model, which has been dominant since the 1920s, has recently been revised. Only 20 years ago, it was discovered that this expansion is accelerating. As time goes on, galaxies are moving away from us at an ever-increasing speed, becoming unreachable even if we were traveling at the speed of light. When we look at the stars whose light has traveled for 100 years to reach us, we are seeing that star 100 light-years away. However, when we look at a galaxy whose light has traveled for 100 million years, we're not looking at a galaxy that is 100 million light-years away. In fact, that galaxy is even farther away. The reason for this is that on larger scales such as galaxies and clusters, the expansion of the universe plays a major role. The longer it takes for light to reach us, the farther away the galaxy is due to the expansion of space. This phenomenon manifests itself as a redshift. As light passes through expanding space, it stretches and changes its wavelength. If the universe were not expanding, the wavelength of the light reaching us would be constant. But due to its expansion, the wavelength stretches, causing the light to be redshifted. The significant redshifts we have observed in the most distant galaxies strongly confirm that the universe is expanding. However, our task goes beyond simply verifying this expansion. We can use the information gathered to understand how the universe has changed over time and what it is made out of. When light from a distant cosmic source travels through the expanding universe, its wavelength is stretched, producing a redshift. This effect is more pronounced for objects that are farther away, since their light has been traveling for much longer. By measuring the redshift of various sources at different distances and comparing their size and intrinsic brightness to what we can observe, we can reconstruct the full history of the universe's expansion. In addition, the way the universe expands is determined by the different types of matter and energy present in it. This allows us to learn about its composition. Approximately 68% of the universe is made of dark energy, equivalent to a cosmological constant. 27% is dark matter, and about 4.9% is protons, neutrons, and electrons. Only 0.1% is made of neutrinos and antineutrinos, and 0.08% is photons. No other entities such as cosmic strings or textures are found. Knowing these components with such precision allows us to apply the laws of gravity according to Einstein's theory of general relativity to predict the future fate of the universe. In doing so, we discover that the universe is dominated by dark energy. This finding implies that galaxies that are not gravitationally bound to us will eventually move away at an ever-increasing rate. As the universe continues to expand unchecked, the distance between us and those galaxies will increase, making them appear to be moving away at an increasing speed. This leads to an even more disturbing conclusion. At a critical distance, the fabric of space itself expands the distance such that a photon leaving our galaxy for a distant galaxy will never reach us. The expansion rate of the universe is so rapid, the distant galaxies are becoming unreachable to us even if we could travel at the speed of light. Although those galaxies are only 18 billion light-years away, the overall expansion is still increasing, and the density of matter and radiation continues to decrease. Our observable universe is about 46 billion light-years across. And if we consider that all regions of space contain an even number of galaxies, only 6% of all galaxies in the current universe are accessible to us. This means that even if we were traveling at the speed of light today, we would only be limited to exploring only a small fraction of the universe. Furthermore, between 20,000 and 60,000 stars go from reachable to unreachable every second. Although the light emitted by these stars a second ago will eventually reach us, the light they emit in the present never will. This fact is unsettling, but it also reminds us of how precious every moment is. From a more optimistic perspective, this reality reminds us that if we ever want to travel beyond our local group of galaxies, which includes Andromeda, the Milky Way, and about 60 satellite galaxies, every second that passes is a lost opportunity. Of the estimated 2 trillion galaxies in the current universe, only 6% are still accessible from the Milky Way. And this percentage is still decreasing. This means that 94% of the galaxies in our observable universe are already out of reach due to the accelerated expansion caused by dark energy. As time goes on, every galaxy outside our local group is destined to move even further away unless we develop the ability to travel to other groups and clusters of galaxies. Otherwise, humanity will remain trapped in our local group, and our ability to send or receive signals from the various parts of the vast cosmos will fade away. The accelerated expansion of the universe is relentless, and the gravity we possess is not enough to counteract it. The universe. The accelerated expansion of the universe is relentless, and the gravity we possess is not enough to counteract it. The universe is not only expanding, it is doing so at an accelerating pace due to the enigmatic force we call dark energy. As this mysterious energy permeates the fabric of space-time, it pushes galaxies apart faster and faster, turning the cosmos into a place of growing isolation. This means that in the far future, countless stars and galaxies that are visible today will slip forever beyond the cosmic horizon, becoming invisible and unreachable. Their light, stretched into oblivion by the rapid expansion of space, will never reach our instruments or our eyes again. What does this mean for humanity and our place in the universe? For one, it forces us to confront a cosmic loneliness that challenges our imagination. We are residents of a fading theater, watching distant galaxies exit stage left in a play that we can neither stop nor rewind. If no new discoveries alter our understanding, then all intelligent civilizations will one day find themselves enclosed within shrinking cosmic neighborhoods, isolated from the rest of the universe. Any evidence of other civilizations, if they exist at all, may be drifting away faster than light can carry their messages. The implications are both staggering and heartbreaking. Moreover, this discovery redefines our timeline for exploration. If we ever hope to reach beyond our local galactic group, we must begin within the limited window we have. In practical terms, that means building technologies that surpass our current capabilities. Intergalactic travel requires more than speed. It demands a revolution in propulsion, energy, and physics itself. We would need to manipulate the very fabric of space-time, perhaps using concepts like warp drives or wormholes, ideas that remain highly speculative but no longer entirely confined to science fiction. Yet, the James Webb Telescope has shown us something even more urgent. The disappearance of 900 trillion stars is not simply a projection of the far future. It is a phenomenon happening now. These stars are no longer visible, not because of time alone, but possibly due to forces or processes we have yet to understand. Some scientists posit that these stars have collapsed into black holes so quietly that no detectable supernovae accompanied their deaths. Others believe that cosmic dust may be cloaking their light, hiding vast star systems in veils of obscurity. But even these explanations fail to fully account for the scale of the vanishing. Could it be that the structure of the universe itself is changing more rapidly than anticipated? Or could there be a flaw in our current models, one that the James Webb data is exposing? Perhaps the laws of physics are not as immutable as we believed. The disappearance of so many stars hints at a shift in the cosmic order, an evolution or decay on a scale that is impossible to test on Earth. If true, it would mean that not only is the universe expanding faster than ever, but that entire portions of it may be undergoing transformations we cannot yet comprehend. As unsettling as this sounds, it is also a moment of awakening. For decades, astronomers have operated under models built on assumptions that worked well for the data of the time. But now, with clearer eyes and better instruments, we are seeing that reality is more complicated. The loss of 900 trillion stars isn't just a number. It's a cosmic cry, a whisper from the edge of existence telling us that our story may be far from complete. Some astrophysicists suggest that we may be witnessing the effects of entropy creep on a galactic scale, where stellar systems exhaust their usable energy and fall into gravitational silence. Others take it further. Could these disappearing stars be evidence of a multiverse interaction? Could there be a force leaking energy or matter from our universe into another? Theoretical physics opens such doors, and while we have no hard evidence to support these speculations, they are no more outrageous than dark energy itself was before its discovery. The universe is not required to conform to our expectations, and if it chooses to fade away in a manner we cannot understand, that is something we must face with humility. In the meantime, the James Webb Telescope continues to scan the skies. It is not just a machine of mirrors and sensors, it is our most ambitious attempt to speak to the past. Every photon it captures is a message from billions of years ago, a snapshot of what once was. As it sends back images of ancient galaxies and distant suns, it also reminds us of the fragility of existence. The stars that disappeared, did they leave behind remnants? Neutron stars? Planetary systems now adrift in darkness? Or did they truly vanish, leaving no trace at all? As we ponder these questions, we must also recognize that every answer leads to more questions. What role does quantum physics play in the large-scale structure of the cosmos? Could a quantum fluctuation on a massive scale account for sudden changes in galactic visibility? Might we one day discover that dark energy is not a constant, but a dynamic force, evolving or shifting in unpredictable ways? And then there is the philosophical weight. If the stars can disappear, so can we. If light can be erased from the record of the cosmos, so too can human endeavor, human history, and human meaning. But perhaps that is what gives our lives their urgency and purpose. The cosmos may be cold and vast, but we are here, conscious, curious, driven. In the face of cosmic erasure, our response must be not despair, but action. Some advocate that we redouble our efforts in space exploration. The Artemis missions to the Moon, the planned journeys to Mars, and the future telescopes beyond James Webb are not just scientific achievements, they are acts of existential defiance. Every step into space is a declaration that we refuse to be imprisoned by the cosmic void. We refuse to be mere observers of the universe's end. We will be its narrators, its storytellers, and perhaps, in some distant future, its architects. Others call for introspection. If the stars are disappearing, perhaps the greatest journey is inward. The understanding of our own planet, our biology, and our consciousness may hold answers to questions the universe is now asking. In either case, the urgency remains. Every year that passes sees thousands more stars become unreachable. Every second, light that could have reached us is stretched into nothingness. The James Webb Telescope is not just rewriting our textbooks. It is rewriting our destiny. It challenges us to look beyond the known, to think in terms of epochs and infinities, to understand that we are not separate from the cosmos but part of its unfolding story. The disappearance of 900 trillion stars is not the end of that story. It is just the beginning of a new chapter. One filled with uncertainty, wonder, and the eternal human quest to understand. And so we continue to gaze upward. With every new image, with every anomaly, with every photon captured from the distant past, we are reminded that the universe is alive, not in the way we are, but in its own strange, entropic dance. The stars may vanish, but our thirst for knowledge endures. The galaxies may flee, but our will to reach them remains. In the ever-expanding dark, we will build our own light, one telescope, one spacecraft, one idea at a time.